Hello everyone, this is Dharmik and I'm gonna give you the brief information about the Mininet, that is how to use the Mininet, how to access the predefined topologies of the Mininet, and how to create the custom topologies of the Mininet. Basically, the Mininet is the simulator to create the topologies. So Mininet itself has like predefined topologies such as linear topologies, single topologies, tree topology, etc. So today we're gonna see the different topologies, and I'm gonna show you all the topologies one by one. To access the predefined topology, we'll start with the linear topology, and for that the command is first of all we'll go inside the Mininet folder. Now we'll type the command here to access the linear topology, sudo mn to start the Mininet, topo, which allows us to create the linear topology or like any topology. Linear define the type of the topology, and for you can randomly choose the number, so it defines the number of hosts in the topology. So in this way we can create the topology. So as you can see, our topology has been created. It has 4 switches and 4 hosts. So host 1 is connected to S1, host 2 is connected to S2, host 3 is connected to S3, host 4 is connected to S4, and this is the linking between the switches. So S2 is connected to S1, S3 is connected to S2, and S4 is connected to S3. So I'll show you the pictorial representation of this topology. So this is how it looked like. So it has 4 switches. H1 is connected to S1, H2 is connected to S2, H3 is connected to S3, and H4 is connected to S4. And this is the links between the switches. S1 is connected to S2, S2 is connected to S3, and S3 is connected to S4. So this was the linear topology. In the same way, we can see the other topologies such as single topologies. So we'll see the single topology. Single topology with the 4 node. It means 4 hosts will be connected to a single switch. So we have created we have accessed the predefined topology of Mininet, that is single topology. So there is only one switch. As you can see, it was here 4 switches. So H1 is connected to S1, H2 is connected to S1, H3 is connected to H1, and S4 is connected to S1. Now I'll show you the pictorial representation of this topology. So this is how it looked like, the single topology. So now I'll show you how exactly this code is working and what is the background process behind this code. So for that I will show you the Python script, because Mininet works with the Python script. So we'll access the code first. So this is the code to create the linear topology. This is what Mininet use. So these 2 lines are for the importing Python libraries. Third line is creating the linear topology. With k equals to 4, it means with the 4 nodes, and this will invoke the Mininet. This line net.start will start the Mininet. Now to test the ping, whether like all the hosts are correctly connected or not, it will ping to all the hosts automatically. So net.ping all, and after that it will close the Mininet, net.stop. So this is the background process behind that small script. Now I will show you how to access the tree topology. So first of all, we have to go back to our Mininet directory. So So we'll type the command. Instead of single, we'll use tree. Here we have to define the depth of the tree first. So depth equals to, let's say, for example, 2, and we have to decide the number of hosts. So for that, fan out equals to, let's say, for example, 4. It means there will depth of the tree would be 2, and 4 leaf node will be there for each switches. So 5 switches has been created. So first of all, I will show you the pictorial representation of this topology so you can understand easily. So this is how it look like. So it has 5 switches: S1, S2, S3, S4, and S5. So S1 is a root node, and S4, S3, S2, and S5 is a child node of the S1. And these are the number of hosts as we have defined. Fan out equals to 4, and depth equals to 2. That is, depth is 1, 2, and fan out, it means number of hosts is 4. So as you can see, S1 is connected to S2. So S1 is connected to S2. S1 is connected to S3. S1 is connected to S3. In the same way, S1 is connected to S4, and S1 is connected to S5. After that, it is creating a link between the host and the switches. So as you can see, S2 is connected to H1, and S2 is connected to H2, as you can see. So now we can check whether like all the hosts are correctly connected or not. So we can ping each and every host of the topology. For that, the command is ping all. It will check the entire network, so it will ping the entire network. As you can see, everything is connected and everything is working correctly. So see, there's nothing dropped. And if you want to check the individual ping between the individual hosts, then for that the command is ping. So suppose, for example, I want to ping from H1 to H5. As you can see, it is working correctly. So this is how you can check the pings, check the connectivity. That's it. So this is how you can access the predefined topologies of the Mininet. And now we'll pass on to the custom topologies. So custom topologies we can define in 3 different ways, or I would say create in 3 different ways. First is, it's really easy. So it's like GUI based. You can access the GUI of the Mininet and you can create a topology directly. Second is menu way, where you have to create each and every host manually. And the third is loop based, where you have to write the Python script, and using the loops you have to create the host and number of switches. So first of all, we'll use the GUI based. First of all, I will show you the GUI based custom topology. So for that, the command is sudo. So you have to write inside the Mininet directory python.example miniedit.py. So it will give you the screen where you can create your own topologies however you want. So for example, I will use this switch. I'll create the small linear topology here. S1, S2, S3. I'll create the hosts. I'll give you the links between each other. So this is a linear topology. So this is how we can keep the controller also here if you want. So this is our linear topology. So in this way you can create your own custom topology and use it directly. Now second method is here we have to create host and switches manually one by one. So I already have written the script for that, which I will show you. So to access that, first of all the custom topology should be stored in the custom directory of the Mininet. So we'll go inside the custom directory first. Here I will show you the code. So this is the manual creation of the custom topology, where I have imported the Python directories, libraries, I would say, sorry. So this is basically a constructor, as everyone knows about the object-oriented programming concepts. So here it will start. So here we are creating host and switches first. So here we are defining left host, that is our leftmost host. So I will show you the pictorial representation of the topology so you can understand easily. So this is how our topology look like based on that Python script. So it has 3 switch and 9 hosts. As you can see, host 1 is connected to H1, H1 is connected to switch 1. So first of all, we'll create the hosts and number of switches through script. So as you can see, I have defined separately, that is left host H1. So this is left host H1, right host H1, and this is that is H2. So right host H1 and the name of that host is H2. So in this way you have to create the host and switches separately, and then we have to add the link between the switches and hosts. So first of all, I have created a link between the host 1 and switch 1, that is left host 1. So that is H1 to switch 1. So it's H1 to S1. In the same way, switch 1, left switch 1 to right switch 1, that is S1 to S2. Sorry, S1 to S3. So it will go like this. So in the same way, we have to create the links between the switches and host manually. So this is how you can create your own topology, and now I'll show you how to access this custom topology. So for that, we have to type a command. So for that command is sudo mn to start the mininet -- custom, as we are using custom topology /custom, like our topology is inside the custom directory and the topology name. So that is example1.py. So it was already created, so I have to remove it first. Yep, forget topo, my topo. So I have to check first of all something is wrong. So I'll pause the video and then I'll continue it again. Sorry, it was my mistake. To access the custom topology, we should be inside the Mininet directory, not the custom directory. So here we'll type the command, that is sudo mn to start the Mininet custom as we are using custom topology. This is the custom directory, and this is our example. So we have created the custom topology as this 3 switch, as you can see, S1, S2 and S3, and these are the links between the switches and host, and we have created the 9 hosts, that is H1 to H9. Now I will show you the third method to create the custom topology. So that is with the help of loop. That's the most feasible method, I would say. So I already have created the topology. I have used the script from the internet and I have made the suitable changes in that so that we can use it. So first of all, we'll go inside the custom directory. Here we'll access the topology. Yes. So this is the Python script to create the topology with the help of loops. So these are the commands basically for importing the Python libraries, and from this part our main code starts, where we can define the number of hosts in our topologies, that is how many hosts you want and how many switches you want. So by changing the value of n here, you can change the number of hosts in the custom topology, and by changing the number of switch here, you can change the number of switches in your custom topology. And basically this part will create the host and the switches, but it won't create the links between each other, because we have to separately link the host and the switches and the link between the switches. So for that we are using the loops. So here we want to connect 10 hosts per switches. So for that I have used this loop where counter start from 0 for both switches and the host. So it says that when counter value of h exceeds the 10, change the number of switch. So I'll give you the picture representation first so you can understand. So this is how it looks like. So 10 hosts are connected to one switch. So we have 5 switches and the core switch, which is connected to 5 main switches. So according to our code, 10 hosts are connected to one switch. So in this way we will connect the host with the switches. Now to link the switches, we have to give the separate commands like add link between the switch 2 to switch 6. So for C, so that is a typo error. This is switch 6 here. So switch 1 is connected to switch 6. In the same way, as switch 2 is connected to switch 6, switch 2 is connected to switch 6. In the same way, switch 3 is connected to switch 6, switch 4 is connected to switch 6, and switch 5 is connected to switch 6. So this was the script for the custom topology, where you can make necessary changes to create your own custom topology. Now I will show you how to access this script via controller, because this script is this topology is really big, so you can't see the picture representation like this. So first of all, we have to start the controller, and for that I'm using the beacon controller, so it would be easy for us to recognize the created topology. So here I will access the beacon controller, or I will start the beacon controller. /beacon. So our beacon controller is started and it is running on port 6633. So we have to keep this port in mind. So first, now our controller is been started, so we can to check whether our controller is started or not, we can check through the browser. So our controller is running on our local host, so 127. See, our beacon controller is up and running. Now we'll access the topology through controller. So for that, command is sudo mn to start the Mininet, as we are using custom topology. So custom./custom, because our topology file is inside the custom folder, and the topology for a file name .py --topo to create our topology, topo controller. Here we are defining a controller now, as it is remote controller running on IP 127.0.0.1, running on port number 6633. So 6633. Yep, it's the same mistake. We have to go inside the Mininet directory, not the custom directory. So our topology is being created inside the Mininet. So as I said, we can't see the representation as it's the Mininet. This topology is too big, but it's already been started, so we can check through this beacon controller. As you can see, our topology is being created, so it takes time, as it's like it has more than 40 hosts. To check whether hosts are connected or not, so we'll ping separately, like H1 to H2. Sometimes it takes time to find out the route, but it will be done shortly. So as you can see, so it started pinging. So in this way we can check for the entire network through pingall command. See, as you can see, H1 is connected to H2. X, it means it is not connected. It's because sometimes the network takes time to find the route to that host. So if the Mininet will send 3 packets, if it won't get reached there, then it will drop the ping. So that's why it is X. Otherwise, like, all the hosts are connected properly. Now to check this number of hosts and switches created in beacon controller, we can go to Beacon, and here we can see on the device manager, but because of GUI problem we can't see. But I have the screenshots of my previous work which I can show you. So in this way, this different switches will be reflected here, and we can see all the connected switches here. And when you click inside the switches, you can see the data flowing through as this, all this like ping data, and it will show the connectivity between the different switches also. So this network is really big, so sometimes it takes time, as I said, but it is all good to go. So I'll stop this ping now, right now. But if I'll see H2 is connected to H1, I can guarantee that it is connected. H2 ping H1. So as you can see, it started pinging. So here in Mininet will only send 3 packets. If it will get dropped, then it will stop pinging. That's why it was showing X here. So this was the brief information about the Mininet and its custom topologies, how to create the custom topologies, and how to access the predefined topologies of the Mininet, and how to access or start the beacon controller, and how you can see the data flowing through the controller. And after that, me or Radha or other person will give you the step-by-step solution for the, or step-by-step points for to use the XTerm and other stuff. So that's all for now. Thank you.